Strange evidence from Mars and the Moon, the proof is out there. When we look at the skies and imagine the red planet Mars or our own satellite Moon, we often think of barren landscapes, lifeless rocks, a cold vacuum. But in recent years, a growing body of strange, unexplained evidence has transformed that picture, suggesting that the story of these worlds is far richer, far weirder, than once believed. From odd rock formations and possible ancient mud cracks on Mars to deep pits, lava tubes and tectonic ridges on the Moon, the proof is out there, if we know how to look. Mars. When stones speak. Mars has long been the poster child for the search for extraterrestrial life and past habitability. Now, more and more, weird finds are sharpening the mystery. Mud cracks, wet-dry cycles in an ancient lakebed. The rover Curiosity discovered what appeared to be ancient mud cracks in the Gale crater region, demonstrating that Mars once experienced wet-dry cycles much like Earth's seasonal change. These polygonal crack patterns were buried and then later exposed, betraying a dynamic past with standing water, drying intervals, and crust-breaking processes. The presence of such cycles is exciting because on Earth they are linked to environments favorable for microbial life. By itself, this doesn't prove life existed on Mars, far from it, but it places Mars into the habitable world category more firmly than ever. Organic molecule signals and the best candidate yet for ancient life. More recently, the rover Perseverance uncovered rock formations in the area of Neretva Vallis, in the greater Jezero crater region, that contain clay-rich mudstones, organic carbon, and iron phosphate sulfide signatures. These are the strongest hints yet of past microbial habitability on Mars. The sample, taken from a rock nicknamed Chiyava Falls, demonstrates chemical and structural evidence consistent with biological processing, or at least with conditions that Earth microbes often exploit. The caveat remains: non-biological processes can also produce these signatures. Scientists are cautious, emphasizing that definitive proof requires Earth-based lab work or perhaps eventual sample return. Rocks out of place, float rocks, and unknown origins. On the 13th of March 2025, Perseverance photographed a strange rock nicknamed Street Paul's Bay, on the slopes of Witch Hazel Hill in Jezero crater. The rock is a float rock. It clearly has been moved from its original geological context, and has a bubbly texture, inviting speculation about its formation, meteorite impact, subsurface explosion, volcanic gas release. Similarly, earlier rovers found rocks nicknamed blueberries, hematite spherules, and zebra-striped rocks, all of which suggest surprising complexity in Martian geology. Moons of Mars, a mystery under the surface. Mars has two small moons, Phobos and Deimos. Their origins remain a puzzle. Radar probing by the orbiter Mars Express revealed beneath the surface of Phobos unexpected structural features, hinting at internal layering, voids or differences that don't match a simple captured asteroid model. A recent academic study also shows that material ejected from Mars by meteorite impacts may have mixed into the regolith of its moons, meaning that Phobos or Deimos captures Mars' geological history in its surface. All these findings from Mars and its moons have three themes in common: evidence of past water and habitability, rocks that don't behave as expected, and structural formation mysteries that push us beyond simple models. They don't yet mean we found life, or alien bases, or ET ships, but the proof of something strange and fascinating is out there. The Moon, familiar, yet strange. Our Moon is among the best studied bodies in the solar system, and yet, it continues to surprise. Surface wrinkles and tectonics on a dead world. We tend to think of the Moon as geologically dead. However, a NASA study published in 2019 found that wrinkle ridges are forming on the lunar surface in the Mare Frigoris region, evidence that the Moon is still contracting as it loses heat. These ridges can stretch hundreds of kilometers, and show that even if the Moon lacks plate tectonics like Earth, it still shifts and changes in measurable ways. Lava tubes, caves, and deep pits. In 2024, radar data from the Lunar Reconnaissance Orbiter revealed a pit in the Mare Tranquillitatis region that leads down to a cave conduit about 45 meters wide and up to 80 meters long, lying approximately 150 meters below the surface. This underground void is believed to be a collapsed lava tube, and it raises profound questions: how many such subterranean spaces exist? Could they harbor preserved records of lunar volcanism, of extraterrestrial processes, or even serve as future shelters for human explorers? Strange bright mantle landforms and ancient landslides. A recent reassessment of an unopened lunar sample from Apollo 17 revealed that the bright streak known as the light mantle may be the result of an extraordinary ancient landslide. The mechanics, trigger and timing of that event remain uncertain, but the clue is that even a surface we think we understand, the Moon, still holds surprises. Asymmetries and odd crustal structure. The Moon's near side and far side differ markedly: crustal thickness, elevation, composition. A recent modeling paper suggests these asymmetries may be the result of a giant early Moon impact event. These kinds of structural oddities challenge simple narratives of Moon formation and demand more complex histories. Water ice, shifting molecules, and volatile oddities. Although the Moon has long been considered dry and lifeless, we've found water ice at its poles and discovered that water molecules move around the surface, being locked in the cold night, then sublimating, then relocating. Also, lunar dust is sharper, more electrostatically active, and more hostile to exploration than previously appreciated. Together, the lunar evidence again shares themes with Mars: geological oddities, subterranean features, preserved records of dynamic processes, and hints of environments previously unimagined, if not of life, then of deep mystery. What counts as proof? The phrase, "the proof is out there," evokes the promise of definitive evidence: ancient aliens, bases, life. But astronomers and planetary scientists caution, proof is hard. Much of what we see can be misinterpreted, misframed, or explained by mundane processes. Here are some considerations. Correlation versus causation. A rock with organic molecules doesn't necessarily mean life existed. Many abiotic reactions can produce similar chemistry. Context matters. A rock out of place, an odd formation, or a pit, all need geological context, history of formation, stratigraphy, and comparison with known processes. Extraordinary claims require extraordinary evidence. If someone claims, base on the Moon, or ruins on Mars, you'll need very strong visual, structural, chemical, and contextual evidence, beyond fuzzy shadowy photos. Anomalies stimulate investigation, not necessarily conclusions. A wrinkle ridge, a lava tube, a strange floating rock, each is a clue. But they aren't full stories themselves. Bias and expectation matter. Humans are pattern-seeking. We may see a monolith on Phobos, or alien tower, in low-resolution images. Caution helps. Putting it together. 3 case studies of strange evidence. To ground this, let's run through 3 concrete case studies. Case 1. Street. Paul's Bay, rock on Mars. In March 2025, Perseverance captured images of a float rock with a bubbly texture, dubbed Street. Paul's Bay. The rock's unusual appearance and displacement raise questions. How did it get there? What process formed it? Proposed explanations include ejecta from an impact, volcanic gas escape, or older processes unknown. Regardless of its final story, it serves as a potent reminder that Mars geology is still doing surprises. Case 2. Lava tube cave accessible on the Moon. The radar-detected conduit under Mare Tranquillitatis presents something unexpected: a hidden void, tens of meters wide, meters below the surface. On Earth, caves like this often preserve environments far older than surface terrain. On the Moon, where erosion is minimal and change slow, such a cave is a geological time capsule, possibly holding records of lunar volcanism, meteoroid bombardment, even water ice. It doesn't prove life, or alien bases, but it is proof of something extraordinary: a subterranean lunar world. Case 3. Clay-rich mudstones and organics on Mars. The analysis of the Neritva Vallis mudstones by Perseverance revealed organic carbon, iron phosphate, sulfide associations and structures consistent with habitability. This may be the strongest candidate yet for a rock that could have recorded ancient microbial life. That possibility alone transforms Mars from maybe habitable to strongly in the direction of habitability. But the leap from that to life existed remains unresolved. Why this matters? Why should we care about these strange finds? Because they help rewrite our story of the solar system, of Earth's place in it, and of the possibilities for life beyond Earth. If Mars once had cycles of wet and dry, with mud cracks, water-rich clays and organics, then life's habitable window may have been broader than thought. If the Moon has caves, lava tubes and complex tectonic contraction, then our nearest neighbor is more geologically alive, in the sense of changing, than we assumed. When we find rocks out of place, moons with surprising structures, and weird chemical signatures, these become clues to ancient processes, even if not life itself. From a human exploration perspective, discoveries of caves, pits, and subsurface voids matter, they may become shelters for astronauts or containers of valuable resources. Scientifically, anomalies force us to revisit assumptions about how planets and moons form, how they evolve, how water and organics behave in space. Challenges and open questions. Despite the progress, many hurdles remain. Here are some of the pressing ones. Sampling and return. Without bringing samples back to Earth for thorough analysis, many claims will remain tantalizing but uncertain. Perseverance's samples may take until the 2040s to return. Signal versus noise. Some weird formations may turn out to be natural geological processes, optical illusions, or instrumental artifacts. The alien door on Mars that made rounds on social media turned out to be a narrow rock crevice. Preservation. Mars and the Moon differ greatly in resurfacing, erosion, atmosphere. What exactly is preserved and what destroyed matters to interpretation. Interpretation of chemical signatures. Organomolecules, minerals like hematite or phosphates. On Earth many are tied to life, but on other planets they may form without life. Origin models. Moons, planets, asteroids all show features that challenge simple models. For example, the origin of Phobos and Deimos is still contested. Asteroid capture versus impact ejecta. Public expectations versus science reality. The idea of proof of aliens is popular, but science moves incrementally. Its pace and standards may frustrate sensational narratives. The future. What to watch for. What should we look for next? Several trajectories are worth following. Sample return missions. When Martian samples come back, they should be analyzed for isotopic signatures, mineral structures, microfossils, if any, and context. Deeper penetration and subsurface exploration. On Mars, drilling deeper. On the Moon, exploring lava tube caves or pits. Moons of Mars. Future missions to Phobos Deimos could sample material that perhaps originated from Mars, giving us ancient Martian surface records in a secondary setting. High-resolution imaging and spectroscopy. The more we look, the more strange features we'll find. Many may be natural, but some might challenge existing theories. Cross-comparison. We must use Earth analogs carefully, but also remain open to processes unique to low-gravity, airless worlds. A note on skepticism and wonder. As we explore these strange findings, it's important to hold two things simultaneously, awe and caution. Awe, because the universe is richer and more surprising than most of us expect. Caution, because our brains are wired to see patterns, faces, artifacts, even where none exist. One Reddit user put it this way: greater than, I'd love to know the actual size since there's nothing to refer it to. It looks like it's heavily magnified. That comment reminds us that scale and context matter enormously when interpreting images from other worlds. Conclusion. The proof may not yet be conclusive, but it's out there. In summing up, the evidence from Mars and the Moon is not yet proof, in the sense of life existed, or alien civilizations built bases. But the proof that something unusual happened, that these worlds are dynamic, complex and sometimes unexpected, is out there. Mars shows us mud cracks in ancient lake beds, organics in clay-rich rocks, float rocks with strange textures, and two odd moons whose origins remain debated. The Moon shows us tectonic ridges, subterranean caves and lava tubes, asymmetries in crust and structure, and water molecule behaviors we once thought absent. For anyone willing to look, willing to question, willing to dig, the proof is indeed out there. And what that proof is exactly remains to be determined.